Hi everybody, welcome to the CodeDam Python Mastery Course Introductory section. So I'm Sam, I'm going to be leading your journey through Python. So first we need to go to python.org and make sure you have Python on your computer. So we go to python.org, downloads, and you can just come here and get 3.9.1. Press the download button. You're going to be prompted with some steps, follow through and continue on, and then your version, what I'm going to use is going to be a little bit different, but I'm going to show you exactly what you're going to see. If you're going to use the standard Python interpreter, idle, shell, you're going to hear those terms, idle, shell, it's going to look like this. And then I call shell the live version, the live television. You can't go back and change anything, and that's fine. And you may have also heard the term REPL. That's what this is right here. It's read, evaluate, print, and loop. Now, for you to get a recorded version, a Python file, you'll come here and you'll click File, you'll click New, and you'll just want to have it side by side. Let me make sure you can see all that. And then you go to File, and then Save As, and then this will change up here into whatever you want to name it. The name of the course, your name, the date, however you want to name it. But that is the standard. Now I'm going to show you what I'm going to use, but it's going to be the same thing. It's just going to look a little bit different. So I'm going to use something that's called Spider, and all this is a little small upgrade. But I still have my REPL over here, and I have my live file over here. So let's talk about what Python is just for a minute. So Python was created, actually it just had its birthday just last month. It is now 30 years old, so it's been around a while. And one of the things that I think makes Python very, very powerful is the community. And right at the inception, it was created by Guido van Rossum as a hobby, as a passion project over winter break actually, and he began getting input from his coworkers, and then it's been off to the races ever since. So Python is an interpretive language, and that's just a fancy way to say it executes line by line, and that's one of the things that I love about it. It doesn't go into a compiler, it just happens right there, and you can understand where the problem is, stop what you're doing, fix it, and move on from there. So let's jump into our journey, and we'll see you next video. All right, welcome back everybody. So now we need to just go ahead and get started. So what makes a computer powerful, a program powerful, programming language powerful, are the two things that people, humans, are bad at. I call this a REPL. Remember, read, and loop. Do the same thing over and over and over again. Those are the two things that a human struggle with. Well, it's perfect for a computer. So in a way, let's first work on the remembering. So variables, that is the main way information is stored. And then that goes into RAM, memory, in your computer, and things are remembered. So we're going to look at the two basic types of variables in Python. So all right, the first is a string, and like I said before, I'm Sam. So the information on this line is, here's the variable name, it's assigned to with an equal sign, and then my information, the information. And you'll notice that some very, very important things are happening right here. So these quotation marks, these are double quotation marks, and we'll delve into that more in depth later. So I want you to use double quotation marks because it circumvents any problems you may have later. So let's make sure, and that is the shift right there beside the enter key, and that's you get the single quote, and then you hit shift and get the double quote. So all right, I'm wrapping my name, SAM, into inside quotation marks. So a computer needs to know when something starts and when something ends. So I'm saying, hey, here's the beginning of a string, here's the end of a string. So I'm taking the variable name, that's the name of this variable, which happens to be name, and then I'm assigning it. In Python, the equal sign links. It links information to the variable. So all right, so now I'm going to hit enter. And it looks like nothing happened. A lot happened. So right here I assigned my information, Sam, to the variable name. Now I'm going to do something that's called calling the variable. So now I type in the same variable and I get the information back. So all right, so that's a string. And I want you to think about this. A string is everything that isn't a number. All right, so now let's look at x. I'm going to assign 1 to x. All right, this is called an integer. Now I'm going to talk about a bit of information that contains a decimal. This is called a float. All right, so now I have a string which lives inside quotation marks. I have an integer that does not contain a decimal. Then I have a float that is any number that does contain a decimal. All right, so let's do even this. This is still considered a float. Even though it doesn't have any value, it's still basically the same, but it's not. It's a float. So all right, these are the 3 types of variables, and we're going to dig deep into these as we continue on with the course. So stay tuned. All right, welcome back, everybody. So, all right, one of the features that Python is built upon is Python basically also acts like a calculator. And these are important because the standard math operators that everybody is used to is completely legal. So we'll delve more into legal and illegal. It's things you can do and things you can't do, or things that will work or things that won't work. So you may hear me, you're going to have a syntax problem, legal and illegal. You're going to hear all those terms, and guess what? We're going to delve more into it. But Python is completely capable of understanding and comprehending this. So your standard math operators. All right. So add, subtract, multiply, and divide. Or actually, I did those in reverse. Multiply and divide. Now you need to know how to handle powers. So let's look at that. So that's double asterisks. So if I'm going through and I want 1 plus 2, I get 3. Now up here, I wanted to show you something. What was that? X is 1. Now this is what is very, very cool about Python. Python knows that this is in memory. All Python does is go and looks in memory, comes back, does this math operator, and then spits out the information. So all right, there we go. Now we need to look at, let's see, let's do TTL, total. So right here, this again, x plus 1. This is an important feature that we need to talk about for a minute. Everything on this side of the equation is done first. Then it is assigned to the variable. So now I come over here and I print out total. Python does not care what this value is. And I'll show you some pretty cool stuff really, really soon. But let's see. All right, now we need to talk about concatenation and adding of strings. So, told you that everything in a string is everything but a number. So, all right, I'm going to show you this. Cat C. Let me show you this. C plus AT. So all right, like I said, this is completely legal. So I'm taking the string C and I'm adding it to a string at. And I get cat. Now, this is where it gets weird. Some people don't care for this. I get it because it's completely legal. So I'm taking the string C and I'm multiplying it by 3, just like any other. So I have, if I were to take 1 and multiply it by 3, I have 3 ones. I have 3, right? So I'll have 3 C's. So this is just one of the functionality of Python, and I want to make sure that you guys know it, and we'll delve into it. So stay tuned and we'll just keep moving. Hi everybody, we're back. All right, the next thing we need to talk about is slicing and indexing a string. So all right, we're gonna up this so we can really get this through. So picture's worth 1,000 words, right? So I've been doing this for a while. So, all right, of course, here's my name. I reassigned name to Samuel. That's my full name, and I like to use this because it can really sell this. So, just like I said, slicing. So we have a loaf of bread, and it's 6 slices long. My name. So now, Python uses a 0 index. So if I were to begin counting, I begin with the 0 part of the number line and go up this way. So if I wanted S, its index is 0. If I wanted A, its index is 1, M, U, E, L, and so on. So if I were to slice out the U, I would use index 3. So let's look at it. Name, and the way that you call an index or you slice, you use the brackets. It's on the line beside the P. It's not the curly bracket, it's the square bracket. And there is a difference between an open bracket and a closed bracket. So you start with an open, just like our quotation marks. Computer wants to know when something starts and when something ends. So we close bracket, 3. I did say 3, right? So we can check 0, 1, 2, 3, the U, right? The U. Bring it back down, press enter, I get U. Now what is very cool is that was an instance, a slice, an index. An instance. Now we're going to slice out. We're going to completely take a chunk. I want S through E. 0 through 4. Now this is super important. Now watch this. Name, 0, we use a colon, not a semicolon. Now I said 4, right? Now you're going to hear me say this a lot. Inclusive, exclusive. The 0 is inclusive. The stop is exclusive. So it goes right up to, but does not include 5. So if I wanted 4 to come out, I have to put 5, and it stops right there before it. It's excluded. The stop is exclusive. So I'll show you. Just like I said, picture's worth 1,000 words. So now I get SAMUE, no L. Now, this is also very, very important. The 0, if I'm starting at 0, is not needed. So I have start and stop. And it is understood that if this is blank, it's 0. So boom. So now let's look at something. So if I want to start at 2 and go to 5, watch this. So I go 2. Now, wanted to go through 5. So I leave this part blank. Go all the way to the end. I don't care how long it is. I don't need to know how long it is. Go all the way through until the end. So boom, I get MUEL. MUEL. So there we are. Start and stop. So the two important takeaways are the start is inclusive, and if it's 0, it's understood to be left blank, and the stop is exclusive. And if you want to go, if it is left blank, it is understood. It goes all the way to the end to grab the last character. You don't need to know how long it is. So there we go, everybody. Let's keep moving. Stay tuned, and we'll see you next video. So now I know I've thrown a lot of information at you, and right now all we're doing is assigning, maybe slicing, maybe calling, but that's not really a lot. So now let's start digging into one of the examples of how I've been talking about how awesome this community is and the things that are already out there for you. So right now we're going to look at 4 built-in functions. So I was calling my variable name, and it comes out with quotation marks around it. So I want to talk about one of the first functions that you need to learn, print. And if you look really close, something happens after you complete the T. It goes purple. I love teaching this function first. Print purple parentheses. So what you'll see is one of the things that Python does for you is that it gives you a guide, it gives you feedback about how things are going for you. So because I'm a horrible speller and I type fast and I make all kinds of mistakes. Okay, so print is, and I'm dyslexic. So, and I see that print is not purple. Oh, I left out an I. So it's a little bit of a double check. Now, I do print purple parentheses to really cement and concrete in that you need to make sure that when you're using a function, you use parentheses. So you use the parentheses to pass in the information. And here's another thing that this even works with shell. Gives you a little gray out, just like another example. Beginning parentheses, end parentheses. There we go. So now when I press enter, oh wow, I get this nice pretty version of the variable. No quotation marks, no anything. So now let's move on to type. So here's another function that is out there. So now I told you name the type of variable that was a string. Okay. The abbreviation for string is str. And then we have f and I believe x. So let's do type x. The abbreviated version for integer is int. And let's keep moving this up. And then we have float. So then we have f. And it spells out float for you. So these are the variables. So this proves that I know what I'm talking about. But you might be sitting there going, why? Why do you need to know that? You just assign them. You just know, that. Well, there's going to be plenty of times that you're going to be getting a variable back and you're going to be trying to do something to it and you're going to be getting this error. And you're going to want to run this function on that variable to make sure it's the type of variable that you're expecting. You're going to get feedback and it's going to tell you, hey, this isn't a float. You can't, it's a string right now. You need to change this and convert it over. And you can't do math with a string, or can you? So now said there was going to be 4. So we did print and type. So now we need to look at dir. I love this function and you'll begin to love it too. So what dir does, if you don't pass any information, it spits out all the variables that you have in memory. But we need to look at this. So dir on str. Oh, okay. What is this? This is all the stuff you can do with that object. So we need to talk about this for a second. Everything in Python is an object. It's information, it's an object you can do stuff to or stuff with. So now, so that was dir on our string. Now let's look at dir on int. Here's everything we can do. And let's look at dir on float. And here's everything we can do with this. So now you might go, well, how helpful is this? Help. So if I pass in help on string, this is what's called documentation. And the further you go along in your learning, in your education, this is where you will begin to go and find out what you need to do and how you need to use it. So I showed you the list dir, and you saw all these little comments and all these little words. These are the things that you can do with them. And this is an expanded version with directions and how they are used. So now if I come down here, and that was string, so this is help on int, same thing, and then help on float. Python never leaves you hanging. The developers never leave you hanging. People who write libraries and modules always have. That's one of the rules of programming. Make sure you have good documentation. So there we go, guys. Stay tuned and we'll keep moving. All right, so last video I showed you and I called this stuff. So I passed in str for dir, str for string. All right, so we need to talk about what these are called. These are called methods. And the way that you use them is, it's called dot notation. So let's look at title right here. And you can really break this down. So we're going to also use our help. So I had str, and I want to look at title. So whatever information you want help with, you pass it in with the object and the method, and then wrap it in parentheses because it is a function. It's a help function. Okay, return a version of the string which each word is titled cased. Okay, more specifically, words start with uppercase characters and all cases are lower. So, okay, so I have name, I already have that capitalized. So now let's look at, what's a good one for this? Let's see what upper does. Help dot str dot upper. Okay, return a copy of the string converted to uppercase. So if I type name, so I want to change my name, and I want to use this. So now, methods are just like functions. We just call them differently. They act the same, so they have the same rules. They still need parentheses. Aha! So now I took name, the information associated with it. Python goes into memory, looks, and then does this method, whatever this method does. And this method returns a copy of a string converted to uppercase. Boom. All right. So now let's look at one more. So now let's look at, let's see, dir on. All right, let's look at one more. So let's look at help, because you're gonna, this is very handy. So str dot split. I love this one. All right, return a list of words in a string using sep as the delimiter. All right, so let's look at another one. So let's just say I change this. I do this in all caps. So now I have name as all capital. And I didn't even spell my own name right. Okay, it's good practice. S-A-M-U-E-L. Fingers don't work sometimes. So now, oh, this is a perfect. So here's something that I'm going to hide in this video that doesn't even have it labeled. Now, this is going to be your life for a while. So you're going to have this, and you're going to be like, no, I typed it right. Let's look very close. Name and name. They are not the same. They look the same, but to a computer they're not the same because one's capital and one's lowercase. Python doesn't care how close you are to what you think it is. It only knows exactly what you tell it. I love teaching young people programming, and they say it didn't come out right, it's wrong. Most of the time it's us. All right, so now let's look at lower. So str.lower. I love these two methods, upper and lower. Return a copy of string converted to lowercase. So name right now is all capital. So name dot lower in my parentheses. Boom. SAMUEL, all lowercase. So there we go, guys. Let's keep moving. Welcome back, everybody. So last video I hid a little Easter egg about syntax. So now we're going to explicitly talk about it. And that's one of the things about programming is be explicit. So, all right, we need to talk about the 3 rules first of variables. So can't have a special character, can't have a space, and can't start with a number. So let's just look at it. F S, okay, invalid syntax. Then invalid syntax, but if I change it to G5 and then I pass in 6, that's completely legal. And then just like this, we can't have, like I said, the space because it's going to read this as an invalid. But this is the standard if you'd like to have words, which that's what we'll really delve into, is that you want to be very explicit and not guess what did I mean by that. You want the variable name, and that's one of the powerful things about Python is there are no limitations on the length of variable names. So type out what it is, call it what it is. If it's a score, call it a score. If it's a grade, call it a grade. So then boom, completely legal. So can't have a space, can't start with a number, and cannot contain a special character. All right, now syntax. Like I said, I hit a little in the last one, but you're gonna have this a lot. Where then in your regular, let's put this over here. It's gonna be our first use of our live. So we're gonna do SAMUEL. So now we need to talk about this. So you can run this. Wow, I cannot type today. Sorry, everybody. So this is going to be the same if you're using this program or the Python file. You go up to File, go up to Run, and then you drop down and you see an F5 button. You can click that or press F5, but your cursor does need to be over here. So I put this into memory. Lo and behold, it runs. Great. Now I do name, and then let's say I leave that off. So I get, this is what Python does. Unexpected, you got a syntax problem. So the editor that I'm using helps me a lot. But if you're in the Python file, the shell file, it does not know, it lets you let it know when it's done. But if you do not close something out, you will get a syntax error. And the way that it typically does, so it tells you where it is, and that's the thing that I love about Python is you begin to learn how to solve problems even before you're really solving complicated problems. You're having to look at the code that you're writing. And here's a very important fact that you're going to hear me talk about. If you get something right, you very rarely don't learn anything. You're going to be wrong a lot, and that's good because you're making a mistake, you're learning something. You're going to learn, you learn much, much more when you make a mistake than when you're correct. Because what happens if you lucked up and typed what you wanted to, and you didn't mean to type that? You didn't make a mistake. I'm fortunate enough that I've made so many mistakes that's why I know so much. It doesn't have anything to do with me being smart. It has everything to do with how many mistakes I made. So all right, let's keep moving, and we'll see you next video. All right, we need to talk about keywords. So what are keywords? So we've talked about functions so far. You know about 4 of them. So now we need to look at what in the world is a keyword. So let's just look at it. So I showed you help when we passed in information. Now I'm going to show you how to look at interactive help. This is where you're going to hear me say this a lot. This is just another example of Python and its awesome built-in features that help us. So I go to my help prompt. You don't have to remember anything. Everything you need to know is in the documentation. Python even has a documentation section. All right. So now let's talk about this for a second. I'm using 3.8. Don't freak out about that. It's September. It's about 4 months old from the video that you're seeing right now. But the only thing that I need to draw your attention to is if you're at either 3.6, I believe this. So if you have 3.6 or below, and that's fine if you do, just you might have your list might be a little bit different. Async, I don't believe. It might be in 7. I can't remember, but I know it's not in 6. I think it started in 8, but it may have also started in 0.7. So there are, but that's just a little tidbit. But basically, our list should be almost exactly alike. So what are keywords? These are not functions, but they have a set of instructions that go along with them. So you can't, basically what this list is for you to know which words to not use variables with, because these have some sort of instruction that goes along with it. And then let's see, we'll use a lot of these, but if you look really close, they are orange. So that's how you know. And it's another thing that helps me, someone who can't type, if I am trying to get from and I go, okay, it's not orange. I did not type it right. So we have that set up. So here's the list of keywords. And if you can't remember, just go to your help prompt and then type in keywords and boom, you get a list of them. So there we go, guys. See you next video. Okay, welcome back, everybody. So we need to talk about loops. So I talked about read, evaluate, print, and loop. So we've already done print. Now the next step that is perfect for a computer to do the same thing over and over again until it's done. And guess what? And of course I can't know my alphabet right now. 4, here we go. Oh yeah, it goes up and down, column to column to column. So here's the keyword for. So a keyword, we're going to know it's going to turn orange, and we're going to use our variable name. Now I'm going to show you something, another little Easter egg commenting. So what I did right here is in mine, it's I comment out a different way, but if you're using shell and the Python file right now, you could highlight everything you want and you do Alt-3, and you can also go up to one of the operations at the top to find it. But you can highlight as many lines as you want to comment out, and then you do Alt-4 to uncomment. So now let's look at the for loop, and that just told me that I'd misspelled for. So all right, for I in, here's another keyword, in. Now we need to talk about everything on this line. There's a lot on this line. For I in name, and then a colon, not a semicolon, a colon. This is called the header. All right, this is what are we doing. Then I hit enter, and you're gonna see a lot right here. I just went to, I'm indenting. Now this is the body. Python does this automatically for you. So if I leave, I think my program doesn't let me leave this off. Yeah, it won't. But if you're in your file and your cursor's back over here, you forgot your semicolon. Excuse me, you forgot your colon. That sounded weird. Okay, so now I'm here, and now, oops. See how I corrected that? I had a problem. I didn't try to fix it. I backspace. That is another. You don't want to try to find and see how you just backspace until you get to the previous line and go back and let Python help you with it. So now this is called, I'm going to show you this, and then we're going to really delve into it. So here's what we're doing, and this is how we're going to do with it. What we're going to do with it. All right. So now I'm going to run. I'm going to press my F5 and I'm going to run. Ooh, okay. This is really cool. SAMUEL. So now you might be saying, all right, well, I just printed out SAMUE, just printed them sideways. All right. So now let's check this out. If I can type again. All right. Okay, so now I did Samuel. Actually, let's leave that there so you guys have a point of reference. And let's copy this. And then I want to go name. So I comment this out. All right. Now, here's the one that's really going to mess with you. So I want to copy this again. And I want to go I times 3. Comment this out. All right, so we need to really talk about what in the world is going on over here. So this is my, we're gonna talk about this. This is called, so name, and then let's go back to our help. And we do help. Get into our interactive, and we do 4. Let's look at 4. What in the world does this do? So it's going through, and this is a type of loop. So it's going to do something over and over and over again until it is exhausted. For loop right here. Then it will iterate over a sequence. So name is a string, but it's also called an iterable. You can iterate through each item. So Samuel has 6 letters. So I want to show you this. Let's rerun this one. 1, 2, 3, 4, 5, 6. So I have 6 rows, right? And I'm going to change this. This is kind of the standard, and I wanted to show you this way. This is called the temporary variable. So I'm going to change, so this makes more sense. Letter. So for letter in name, this iterable, I want you then to each time through, so all it's doing is counting how many letters are in there. Then I want you to take each letter, and I want 3 of them printed out each time. So that's what we're doing here. And this is one of the most powerful tools that you have in your toolbox, is to loop through something over and over and over again. So, all right, let's keep moving. See you next video. All right, so now we need to talk about a way to begin to take control of what we want to do. So we've seen 4 functions that Python has for us. And we also saw some keywords, and there was one called def. So we know how to take a header and work with a loop. Now we're going to learn how to take another keyword and create our own function. So a function is the smallest amount of repeatable code. So it's really the smallest program possible. So we're going to just create a program, a function, that just says hello. So now, again, 5 things, but one of them's optional. So we have 4 things that are super important in our header. Def, the keyword, and as you can see, it's orange. Then my function name, then my parentheses. Just because we're making our own, we're not special. We don't get to deviate from the rules. Functions have parentheses, so we have to use parentheses. Now, optional. The option is information inside, and we'll deal with that later. And then we need to close it out with our colon. So now, where it's not going to be too extravagant, our function is just going to be pretty standard. So when we call this function, it's just going to print hello. So I'm going to put this into memory, and we look at it and we go, oh, wow, nothing happened. Well, no, a lot happened. So I'm going to show you. Function in the main, hello. So now I left off parentheses because I didn't call it. I just wanted to know about the function. So now let's do this. So now I want the function. I want the function to run. I didn't want to know about it. I didn't want to read it. I want to use it. So I use my parentheses. Boom. Hello happens. So now I could have a set of endless functions in the body. Still same rule. Header, body, all indented. And we're going to delve into this. Print, hello, how are you? So now, all right, now we need to talk about this for a second. Python says, hey, I'm going to stay in the body. I'm going to stay indented. And if you look over here in your section, right, I got line and then column right behind me. You can see, let's come over here and shrink me down just a little bit. See. All right. So you see column. So that's what line I'm on. So now all I do to get out of this is backspace. But no, this is an important feature in Python. It counts white space, it counts indentation, and we're gonna delve into this. But this is a very important feature that you need to know. So now I want to show you this. Let me put some space in here. Again, this is completely legal. So you're saying, well, you're calling it init. No, if I was indented, I would be init. Right now, I'm outside of this function. I'm still in the program, so it's legal to call a function in the program. So now when I run this, I don't have to call it over here. It will run. So boom, here I am. I'm now saying when I run this file, I want you to then run this function. Hello, I have a space. How are you? And this is the way that Python just becomes unbelievably more powerful and more powerful. All right, and we need to talk about this. So we're going to go def hello. Don't know why I keep doing a 0. Twice. And boom. And then I call hello. Hello. So here is another legal operation. This is where it is. So I have a function, a very, very short program, the shortest of programs that we can have. Something repeatable. I've written a piece of code. I don't want to have to remember it. I don't want to have to retype it over and over again. I can call it. Now, you can create functions to call other functions. So now when I run hello twice, it goes and calls this function 2 times, then extinguishes itself. So there we go. And let's say I wanted another little line, or I wanted some other message. I put it in here. I run it again. Hello, how are you? Hello, how are you? Boom. This is where you begin to become a very powerful programmer. So there we go, guys. Stay tuned. See you next video. All right, the last thing we need to talk about is a docstring. Like I've been talking about documentation and how Python just has it everywhere. Well, we need to do the same. So generate docstring. So you're going to hear documentation, docstring. So this is what it does. This function prints hello. All right. So this is all this function does, right? So I close this out, put it back into memory. So then when I come over here and I begin to type hello, boom. Oh, here we go. Whatever you put in the docstring comes out here. So if you come and look at print, let's run help on print. Okay, everybody look really, really close. See any similarities? It's the exact same information. So if I run help on hello, this I get here, boom, this function prints hello. And then we come down here and you do the docstring with 3 double quotation marks. This function calls hello twice. But again, it doesn't matter. It's whatever you put in here. So now I run this and I call, let's bring this up here, call hello x2. Oh, type too fast. So if I type it correct, boom, this function calls, spelled call wrong, calls hello twice. This is how you become successful, because look, when you move on and you're working with other programmers, you need to tell them what it does, because you're going to begin to write these programs, and at the start you're going to have very small amounts of information. You're going to come back and look at it later, 2 months, 3 months, 6 months later, and you're going to go, what does this function do? This is why you want to make documentation. And one awesome way to do it is put a quotation mark. I wanted space between calls. So I'm putting a comment here, and anything after the comment, Python just stops reading. So this is completely legal and runs and does not throw up. So it's like, okay, what did I do here? Oh yeah, I wanted to have a space between the calls. Okay, that's why I did it. Boom. And then when somebody is using your function, well, what does this function do? And they have it right here. Everything else. Just good documentation. It's a great practice. Let's start at the beginning and make sure we have good habits. All right, stay tuned. See you next video. So now we need to talk about some way to hold variables. So I showed you dir on str. I'm going to bring your attention to something right here. You might recognize these little square brackets. So there are things called containers, and there's 3 main containers. You have lists, you have tuples, and you have dictionaries. And they all have different functionalities. They all have different purposes. But I really want to draw your attention to this right here. So now I'm going to show you something that is going to be a little mind-blowing at first. So, like I said, Python doesn't care about things. So this returns, creates, we're going to talk about return really, really soon, creates a list of methods. So now if I do type on dir on help, so I have 2 sets of parentheses. Now I call this, boom, I get a list. Python completely understands that this returns a list, so it doesn't care what this instruction is. So the first type of container we're going to look at is a list. And what does a list do? It holds stuff. It can hold variables, it can hold information, it can hold other lists, it can hold other containers. So let's just slowly walk through this. So first we're going to make an empty list. Then we still have F and X and name sitting out there, right? So I'm actually going to place all of these variables inside list. So now we need to look at things we can do with a list. Here are our methods. And I love showing append first. So we need to learn how to do this. So we're going to look at now. Also, what did this do? So type list. So dir list. All right, so then I do help. You can either do the variable or the object. So I'm going to do my variable, and I need to know how to use append. So, all right, so I use lappend, and I place an object. It appends the object to the end of the list. So right now I have a list that's empty. So first I want to pass in and add to the end of the list append. So now this is going to be our first example of how to pass information in through a method. So first I want to put in X. Now let's look at list. So it went there. Now I'm going to do append Y. All right. Now I put in, okay. I meant to do F, but now, okay, I'm going to put it in there. Append F. All right. It will go to the end of the list. So now I want to put in name. And let's call it one more time. So now I have a list of 4 items here. So this is our introduction to containers. Now we need to learn about what a dictionary is. So now I talked about square brackets. Now let's talk about curly brackets. So now I've created a dictionary, empty dictionary. And we're going to run help on, well, let's first look at the notation. Dictionary, dict. Now, let's run help on, boom. Ho-ho. All right, so here is everything I need to know about a dictionary. We can do all kinds of methods. We have keys, and the main feature about a dictionary is a key value pair. It associates information to a key. And we're going to delve more into this. Now, the third container that we need to know about is called a tuple. And it lives inside parentheses. And the biggest thing about a tuple is it has a lot of the same functionality. Let's call type on T, tuple, and then I'm going to run help on T. So now, the thing about a tuple is it's a lot like a list. But now let's learn about some new words, mutable and immutable. Mutable means it can be changed and moved around. Immutable means that is it. So when you create a tuple, those things cannot be moved, where things in a list can be. So I could run some things and move a list around, and we'll delve much, much more into this. But a tuple is fixed. So that's what you need to know. And a dictionary is associated with a key and value pair. And again, we'll delve into this much, much more very, very soon. But just wanted to make you give you a small little taste. So stay tuned, and we'll keep moving. See you next video. All right, everybody, we need to talk about conditions, testing. We need to dip our toe into it for our next little step. So we're going to talk about booleans, true and false, however you want to think about it. So let's just go ahead and get after it. So we do help and we do true. Well, let's look at our keywords. So these are two of the three that are begin capitalized. Everything else is lowercase. You probably already noticed that. But true and false. And don't overcomplicate this. True is true, false is false. So let's really examine. So we have one. Now, you've seen assignment with one equal sign. Probably threw you off a little bit because you're used to, in math, having equivalents. Well, in Python, we use equivalents with two equal signs. So, does 1 equal 1? True. Does 1 equal 0? False. Now, there's also a way to handle a not equal, a false. So, this is the exclamation point and an equal sign. So, does 1 not equal 0? True. So does 1 not equal 1? False. And then you can also use this right here. Does true equal true? Yes. Does true equal false? All right, let's do one more, and then we need to really move into the meat of this. All right, because we're going to build upon this next video with some instructions. All right, and this is the building blocks of conditions. All right, so let's move in. All right, so 1 greater than 0. Is 1 greater than 0? Yes. All right, is 1 less than 0? False. Now you need to know this. Okay, there's also an equivalency. 1 is also, so true can also be 1. So 1 can also be true. So if I were to, and then false can also be equivalent to 0. All right, so let's say that again. So these are not the same, but they are equivalent. This tests for equivalency. So true is equivalent to 1, and false is equivalent to 0. So now, 4, is 4 less than 0? False. You can also throw in, so we have equivalent, not equivalent, greater than, less than. I think we did greater than, less than. Yes. And then greater than or equal to. So is 1 less than or equal to 0? False. So is 1 greater than or equal to 1? True. So we have greater than or equal, and that is going to be, we're going to build upon this in our next video with some math operations. So we'll see you then. All right, welcome back everybody. So now we need to talk about a little bit, still beginner, but dipping our toe into how to handle reassignment, incrementation, in-place operation. So all right, because we're going to build upon this. So right now I have x, and x has 1 assigned to it. So x is equivalent to 1. All right, so now I've made a passing comment that Python does not care about other variables. So now this is how much it really doesn't care about what the value and the assignment of things. So I'm going to show you this. This might be very foreign and just really odd because you're like, well, how does this work? So the way that this works is Python goes into memory and goes, okay, I know what x is equal to 1. Python does everything on the right side of the equal sign first, then assigns that information to whatever variable we have. It does not care what any of this information, whatever the variables are on this side, it does not look there. It just looks to this tells Python where to go look to get this information. Then Python disregards the variable, and then what it does, whatever operation this is, then assigns it to this variable. So now x is 2. Now I'm going to show you the shorthand of this. Plus equals 1. It's supposed to be 1. So this is incrementation, in place operation. However, reassignment, because right here is reassignment, all the same thing, incrementation, reassignment, in place operation. So I'm telling Python to increment this by 1. So next video, we're going to build upon this, and it works with all operators. So let's look. So we have x equals -1. So now x is back to 2. It was 3. So now I want to take an increment by a multiplication of 2. So now x is 4. And then if I want to divide by 4, I get 1. Now, a little bit of information here, and we'll delve into what is happening there later. But this is incrementation, reassignment, in place operation. So we'll continue building. See you next video. All right, so now we need to talk about while loops. So we're going to put this all together. So we now know how to assign, we know how to do math operations. We begin to, well, we need to look at what while loop does. So what a while loop does is it's our first little blend of a loop with a condition. So this is our first step into checking if something is happening, then do something until that situation doesn't happen anymore. So do until true and then stop, or do something else. So now I'm going to do something that's hardwired. I'm hardwiring in something true. Oops. All right, now I'm going to show you with your version. So I'm going to show you how to cancel a while loop, or something that you got stuck and you need to know. So let's draw our attention to, so I'm hardwiring this true. So there's no way to change this. Print hi in our situation. So I want you to look at this. So I press enter. Python is sitting here going, do you have anything else? No. So I'm on line 5 right now. So I want to draw your attention to that. 5. I come up here to shell. Oops. Yeah, shell. Restart shell. I was on line 5, right? That ran, in those few moments, that ran 300 times. All right, so let's come over here to mine. Print. Hi. Close this out. Run. Boom, I'm running, continuously running, and I stop. And I interrupted with the keyboard, so I kind of cheated. So, but that's your first foray into this. So now, let's do some stuff where we're checking. So I'm assigning 1 to x. So while x is less than 10, so now I hardwired, this is our first condition. This is our first comprehension of what a condition is. I'm saying do this while true. This is only when we're dealing with conditions. These only happen while this is true. That's it. Now there's a way to handle not true, but you still make it true. And we'll see that very soon. So do this until it's not true anymore. So all right. So we learned last video how to increment. So I'm going to increment by 1. Print x. So now, all right. This is going to happen until this stops being true. So let's run this. Very cool. So I have 2, 3, 4, 5, 6, 7, 8, 9, 10. So once this became false, this stopped. Now, I want to show you this right here. We're going to mess with order of operation. So we have while x less than 10, print x, close this out, then increment. So I tweaked this just a little, just this little order of operations, and this is a little hint in here that I'm not talking about. We'll delve more into this. So I run this. It stops at 10. Now if I call x is 10. So I want to talk about this. Order of operations. So I'm printing x, then I'm adding 1. So then it got up here, failed because this was 10. Then it spit out, and there was no more program here, so it just ceased. But then when I called x one more time, it still added this because it's in the body of the instruction. So it printed it the first time. Unlike where I had these in reverse, I got 10 to come out. But these are the building blocks of control of what happens, flow, and order of operations, and conditional statements. So there we go, guys. See you next video. Okay, so last video we dipped our toe into conditions. So let's just go ahead and jump all the way into it. So we need to learn about 2 more keywords, if and else. So basically, if true, so we learned about while and while true. So now, if something is true, do this, else do this. So basically it's, if that's, well, let's just start. So we have x equals 1. If x less than 10, print yes. Oops, stay consistent. Yes. All right, so we run this. Lo and behold, we get yes. So now let's change this. X equals 10. I run this. I don't get anything. So here's a perfect example of this condition has to be true. So I touched on it with our while loop. This will only happen. The body Python's rule is the header has to be true. Then the body gets the approval to run. So we need to have a way to handle if it's false. Now we could hardwire this and say if, but I don't want, I want it to be if it's less than 10, do this. If it's not, do something else. Else, print no. So this is how you need to think about it. There's 2 ways to think about this. If it's not this, do this. So if this is true, do these set of instructions. If this is false, do these set of instructions. So now I get no, and if I comment out this one and uncomment this one, I get my yes. So here's your first little dipping our toes into conditional statements, how to work with if and else. All right, see you next video. All right, so the next thing we need to learn about is how to handle remainders. And Python has an awesome operator called modulo. It's the percent sign, but I want to show you this. And this is a very handy tool. So now I'm going to explain this the way that it took me to figure it out. So it is what is left over after you take this and you divide it by this. So if I have 3 and I divide it by 2, what is our remainder? It's 1. So if I have 5 and I divide it by 3, 3 goes in one time, and the remainder is 2. So this is a very, very powerful tool. So our next experience is how can we find out if something is an odd or an even number. The way that I want you to think about programming is, can you explain it to a 5-year-old? If you can explain it to a 5-year-old, where you can write it as a program. So let's look at this. So an even number is a number that is divisible by 2 with a remainder that goes in evenly. So we're going to start there. So 4 divided by 2, it's evenly divided, right? So another way to put this for the tools that we have so far is a number divided by 2 with a remainder of 0. Okay, so now how can we write this? So I have x, and it is equal to 3. So if x modulo 2 equal 0, all right, so let's jump back over here. So we're slowly merging and putting everything we know all together. So I have 4 modulo 2, 0. Just like I showed you how we took help on a certain object and that returned a list, Python does not care what this is. It understands that it returns 0. So this is a completely legal statement. So I will show you long form right here. Just like this. True. Python understands that, of course, this is 0. And it understands that this is 0s too. And we're testing the equivalency. Is 4 modulo 2 equivalent to 0? And of course, the answer is true. So now we print even. Else we print odd. So now let's check a couple of these. Odd. All right, let's change this to x equals 4, and x equals 5. So we comment that out. So now we run that. It's even, comment, uncomment, odd. Very, very, very cool stuff. So this is how we build and we expand our knowledge and our understanding. And this is a fantastic tool for us to understand how to take information, make a decision, and have something happen. So, all right, there we go. See you next video. All right, so where we were last video is we created some very cool things, but the way that we went through them was kind of absurd, and I hope you kind of felt that way, that we were just testing one at a time. So now I'm going to show you how you can test more at one time with one feature. So like I was showing you, we learned about a list, and so we're going to create a list right here, and then we're going to iterate over this list. Fancy way to say go through this list and then test this information. And this is exactly how we're going to do it. Just like we iterated over our name variable, you can literally use a for loop to iterate through a list. Any iterable. So for number in L, I want to if number. So now here's the important part. If number divided by 2 equals 0, and then we're gonna talk about it. It's even. And then else print odd. So I hope it's drawing to your attention that we have now multiple layers here of indentation. So here's our header. here's our first condition. So it's going to come down here one level, test this condition. This is just now another header for a body of instructions, however many you need. We're just going to use one, and then if this is false, do this. So each time through, and I want to really draw your attention to this right here. Actually, I'm supposed to have spaces here. This is our iterable, all right? This is our list. And then each time through, actually, let's do this right here so we can do this, because I jumped a little bit of a step. I felt you were ready. So for I in L, print I. So all it's going to do is just print the contents of this container. Boom, just like this. So now as I do this, check, do, and if it's false, do this. All right. So now we have odd. Oops. Comment that out. Don't need that. So that's why we have an extra one. Odd, even, odd. And this is now how we become very, very controlled and have repeatability. And next video, we're absolutely going to show repeatability. So see you then. All right, welcome back, everybody. All right, so this video, we're going to look at, because right now you need to have all of this, and I would need, if I wanted to use this later, I would have to copy it. So I'm going to show you how to just wrap this into a function. So we're going to call this is even. We're going to pass it a list. We're going to do a very good job. Checks items in tests. We're going to call it tests. Tests numbers in list to see if even. 1, 2, 3. Close this out, and then literally we're just going to all right. So now I go is even. I'm going to pass it L. So now we need to talk about this for just a second. So just like here, this is my variable here, number. Do this to the contents of our variable. Now, this is where you get this information from. So I'm saying, look, here's my variable L. Actually, we need to change this to no, I don't want number, score. All right, score. All right, don't want any confusion. I really want to explain this and bring this home. So like in our for loop, here was our temporary variable. I'm saying, hey, this is what I want you to do with this temporary variable. And then now, let's comment this out. Now, down here, we're going to pull that from here for our score. So let's look at this. So now here's our optional fifth. So I'm passing in stuff. So I have my 1, 2, parentheses, variable, optional variable, information, and then my colon. So I have all 5. So now I'm saying, look to here. Python doesn't care what it is. Okay, it's a list, it's an iterable. I can iterate through this. Now, when I call this, remember when we go outside our function, I'm calling this function and I'm passing this information. So, all right, let's run this. Boom, same thing. But now it's repeatable. I can use is even over and over and over again, or even have this in a file and send this to somebody, and they now know how this works, and they can pass it a variable, whatever size of list they want to test. So this is how you wrap information into a function with a very good doc string and run it. So there we go. See you next video. All right, so welcome back. The next function we need to talk about is the range function, because it is very powerful and very, very handy. So, all right, so what does it do? It returns an object that produces a sequence of integers from start inclusive to stop. It's all going to sound very familiar. Return an object produces a sequence integers from start inclusive to stop exclusive by step. So let's look at it. So if I call range, so if I get my range and I pass it a number, call R, I get 0 to 10. All right, so let's look at this. So I call range, start, stop, step. So what does that mean? Has a starting point. So if I just pass it one number, one integer, it understands that it's going to start at 0. It's just like our slicing. And this is going to lead us into something else very soon, next video. So it's going to stop at 10, but it's exclusive. So it's going to go right up to 10, but not included. So let's look at this. So for I in range, so this is print I. So what did this do? So if I don't pass it a second number, if I just pass it 1, that's the stopping point, and it understands to start at 0. So 0 is inclusive, included, 10 is exclusive, up to not including. But I have 10 numbers. 0 is a number too. We got to count it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 numbers. So now let's start to tweak this and really experiment. So for I in range 1 through 11, print I. So what is going to happen? Now I have 1 through 10. Because I said start at 1, go through 11, exclude 11, so I wanted 10, and then just print those out. Now we need to look at the last little piece of range, step. Oops. Step right here. So what does that mean, step? For I in range 2 through 11, step by 2. 2 through 11, so not 11, so 2 through 10, so start at 2, go through 10, step by 2s. So every 2, 2, 4, 6, 8, 10. So now if I wanted starting by 3, how would I get 3, 6, 9? So what would I need to do? So this is an important piece. So when you're using steps, so I don't have to have this to be 12. So for I in range, it's just to include the next number. 3 by 14. Yeah, by 3s. Close this out, I. So if I keep changing this, if I make this still, and I can even go up to 15. If I can go up to 15 and I still have that, I have to go up to at least 1 larger. So if the step is included, not excluded, then I can get 15 to come out. So there we go. Thanks for watching. See you next video. All right, so building along on top of last video with slicing using start, stop, and step. So picture's worth 1,000 words. So we're going to slice using start, stop, and step. So I have A and U blocked out here. So I have name, and I assign Samuel to it. And now I'm going to print name, use my brackets, start at 1, go through, where do I want to include? So I want to go to at least 3. So if I want 3 included, I have to go to 4. All right, so 4, then step by 2. So let's run this. So I get A and U together, just like A and U. So I can go and we can change this up, and we can print a couple. Print name. Then we're going to do this a couple of ways to really get this through. So I go by 2. So I'm starting at 0, going 0 by 2. So it's going to be 0, 2, 4, but not 6, right? So then I run this, and I get SME. All right. So then if I do, now I'm going to leave this blank. Print name. I'm going to leave stop blank, so I'm going to go all the way to the end. So now if I go boom, I'm going to leave start blank and stop blank. This is how we do this. Start at the beginning, go all the way to the end, but go by 2s. So actually it should be the same. I didn't think about that. So all right, let's go by 3s. All right, so what is that? So I get S, U, S and U, and that's it. So this is how you can slice and begin to pick out and control any repeatability that you want. One of the simplest ways to do code. So you go through as a coded message. Send a message, but you're only using every 3rd letter or 5th letter or some random pattern of letters. But this is one of the building blocks. Start, stop, step. Same rules for range and slicing. Start is inclusive, stop is exclusive, and step is just like your multiplication table. So there we go. See you next video. All right, everybody, welcome back. So the next keyword we need to look at, well, let's just get it in here, is import. So what in the world does import do? Well, it does something that you can probably guess. It imports something. So in Python, what has already been downloaded onto your computer are a number of other Python files, and they end in .py. So now we typed in import, and this is the very cool thing about help. It leads you down a rabbit hole. Modules. Oh my goodness. So what does modules do? Okay, so these are files. This is activity that Python has already done for us. So let's just look at a couple of these. Oops. So one that I like a lot is math. So what this is this is a file that has all kinds of stuff already created for you. So here is pi, and then let's bring in random. So here's another module. So dir random. So there is a way for you to shuffle things, get random numbers, make random choices, and things like this. These are the tools that I alluded to in earlier videos, that there are things that have already been done for you that you're going to use it through your time learning Python and through this course as well. So just another very powerful tool right here, and we will delve into this very, very deep. So, all right, see you next video. All right, everybody. So the last thing we need to know in this section before we move on is return and none. So what is this? So keywords. So we have none, and then we have return right here. So return creates, none is nothing. So let's jump at it for a minute. So right now, print it returns none. It just prints output. Nothing is created. So let's see. So I have name. Is name still there? Yeah. So if I take X, then I assign it to name. So it print out, but nothing is created. But when we use a return function, let's look at this. So now we look, and I know this is going to get very tricky very fast, but this is why we have this. Here we go. If called without an argument, return the names. So we have something created, right? Remember how we took and we made, so I take our L and I do dir on it. I created the list. I created something, my L, my list. Whenever you see return, something is created. When you do not see return, or you see none created or in place, it means it's changed. So like when we had name and we did upper, let's look at help and upper. Help name dot upper. What does this do? Return a copy of the string converted to uppercase. So if I go new name dot upper, it spit out Samuel as capital, but did not change the original. It creates, but since I didn't assign it to anything, then when I go name dot upper, just two P's, so now nothing happened, but we know something happened. So now I still have name, but now I have new as well. So when you see the word return, you know that something is created. So all right, now let's take a function and make something. All right, def, we'll just call it double. Double. Take in a variable, close this out. First we're going to do print. And we print double times 2. We'll stay consistent with our rules. All right. So then double, call it, pass it 2. Actually, here we go. So I get 4 because I called it and it has a print. But if I have new, I have none. We're not creating anything right here. But if I comment this out and then I return, now return does not need parentheses because we're returning everything after. So here we go. Now when I call, because I had no instructions, so nothing came out. So now when I call new, I get this. I created something. I returned something. Something was therefore created. Now, let me show you a little tidbit. This is kind of cool. Cut, little Easter egg. So, dead code. Print won't happen. Whenever you see return, Python stops. So this is a way to control your code. So when I run this, print won't happen. But if I have this up here, if I have a copy of this and I run this, I will get it one time. But if I comment this out, this is after return. Python goes, I'm not doing anything. So this is a rule that Python has. Python has rules because Python's a programming language. It is written in a programming language, so it has rules too. So there we go. This is the last video of this section, and we're just going to begin moving on. So we'll see you then. See you next video. Hi everybody, welcome back to the beginner section of CodeDam Python Mastery course. So, alright, I know I threw a lot at you, and let's just kind of retool and dig back into it. So, I have some information over here on the screen. So I have Sam plus Samuel, or Yule plus Yule, then F equals Sam and L equals Yule. So I ran this right here, but nothing happened. Well, not true. A lot happened. So you're gonna hear me talk about legal and illegal. This is completely legal. I just didn't do anything with this. This is just because this is over here in the script in the recording section, and this is the REPL, the live interaction. But I did do things here because I have an equal sign. So I assigned information to 3 different variables, but I have no output. I don't have file. I'm not putting it someplace. I'm just assigning this information. So let's just kind of look at this now. So I got F, okay, Sam, L, the Yule, and full is Samuel. So we are going to now start looking at how we can use these things. Okay, so now we need to talk a little bit more about indexing. So let's comment this out. All right, so let's just say I have numbers here, and we're going to put this in 2, 4, 6, 8. So now I want, I know this can be very, very challenging at first, but once we talk about it a few times, it will begin to make sense. So when I put this into memory, I have numbers. So what is numbers? It's a variable. What type of variable? Well, we use our type function, built-in function, to get this. But we know strings live inside quotation marks. So I put digits, not numbers. So I have this assigned. Now, we need to look at some slicing, and I need to show you a little bit of a different type of slicing. So we looked at in last section numbers 0. It is a 0 index, so 2, index 0 is 2, so index 1 is 4, index, oops, I just flipped that around, then index 3, 0, 1, 2, 3. So let's just knock this out. 1, 2, 3. 0, 1, 2, 3. So 2, 4, 6, 8. Now, there's something called 0 indexing we need to look at. So it's not going to be 0 and then negative 1. So negative 1 goes in reverse. So we saw our example last time So if I have, let's just put Samuel back in memory. Name equals Samuel. I can spell my own name. So now let's put this back up here. So not only can we forward index, we can negative index. So if I wanted L to come out, I don't have to know, I don't have to count. If I just say, hey, I want the last item in however long this is, name, -1, I get L. Now, here's my example. Boom. Boom. If I want -4, the -4th index, 1, 2, 3, 4. -4 will be M. So boom. -4. Boom, I get M. So we need to talk about that for a second. So now we need to talk about something else. So we have these numbers. And then if I slice out numbers and I get 2. So if I assign numbers index 0 to X, I have a string. So if I try to do any sort of arithmetic with this right here, I'm going to have a fail because it is expecting me to be concatenating a string because the first object is a string. So if I do this in reverse, it's going to say that I can't do this math operation because it does not match. So there is a way around this that the core developers have helped us out with this. So we're going to take, so when we had a number, let's just take y and we assign it 1. And we use our type function with y. We get an int, right, for integer. So I can actually take, there's actually a int function, and I can wrap a string, if it is a digit, it needs to be a digit, and we'll delve way deep into this later, but we're in the beginner section. We're just having fun. So now if I put a string in here that is a 2, well, actually, no, we'll do baby steps. So now X is 2. So now if I come up here and I slice out and I go y equals int, and then I go numbers, and I slice out my first index, I get my 2. So, and the reverse works the same. So now let's get on to some exercises. Okay, so now we need to talk more about methods. So we're going to put name back in memory. And we got good old Samuel. Boom. Now, we're going to look at dir str. And these are all the methods that you can use on a string. And that's just a fancy way to say what are some of the things that we can do with Samuel. Now, you can view these one of two ways. You can come in here and you can run help on str or even name. So it works. Oops, I forgot strings don't do this. So help on str. So here we go. Let me slide this over. Boom. So if you remember, and I know there's a lot there, but these are each of the methods and a description. And you do not have to run help on all of these every single time. So we're going to do one of my favorites first, and it really brings things home. So right now we have name, correct? And it's capital S, lowercase a, M-U-E-L, right? Okay, so now if I can look at, let's do dir on str. And I have lower right here. So methods and functions behave exactly the same. So they need parentheses, but the way in which you call them are different. So since this is a method associated with an object, a string, you will then call the object that which you want this method to happen upon lower, and you pass. So now what this did is it took Samuel and lowered all of the, so if I were to change this and go caps lock S-A, actually no, I want this to be, I want you to see every S-A-M-U-E-L. Wow. All right. And caps lock on, S-A-M-U-E, caps lock on, S-A-M-U-E-L. So now, we'll call this caps. So then now I have caps and I have name. So now let's do a laser focus on name dot lower. Now since I'm just calling this method, I don't need to add the parentheses. I'm just wanting to refer. I want Python to go out, grab all the information associated with lower, a string lower, because we can come all the way up here and look for lower, and it will be the exact same. Boom, just right here. So now we come down here, exactly the same. So we need to read and understand this really fast, really quickly. All right, so what does it do? It returns a copy of a string converting to lowercase. So right now, when I call name again, nothing happens. So I would need to name dot lower. So now I have name, Samuel, and I have new, or I guess I should have called it lower. So we got name dot lower. So in the assignments, what I'm going to do is I'm going to show you what I'm going to want, and you're going to need to look through. Of course, the first one is going to be uppercase, all capital. You can figure that one out. But then I'm going to have one that is not going to be so easy, and you're going to have to read the documentation. So that's where the adventure in this is starting. So good luck and see you next video. Okay, welcome back everybody. All right, I want to delve more into the keyword in. So we've already seen and dealt with for I in range, blah, 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 and we used a for loop, right? Okay, so we got numbers right here, right? Numbers, and I have, it's a string, 2, 4, 6, 8. Now check this out. 2 in numbers. So all right, in is a keyword that does a lot of things. You're actually either asking or you're going to be using the temporary variable. So in our for loop, we were using a temporary variable and saying this is what you're going to use it in. Now, this is a basic test or a question. So is to, so the way that I did it and I learned it first was I always would add the is in front of the condition. Is blank this? Is this true? Is 2 in numbers? True. Is 0 in numbers? No. And same thing with name. So here's a great one. This is a perfect example. So we got name, it's capital S-A-M-U-E-L, right? So is in name. So I want you to look real close. That's a lowercase. No, lowercase s is not in name. So there we go. We're going to begin to do some more with this, and good luck on the exercise, and see you next video. Okay, we need to talk about, we're going to look at lists. We need to talk about mutable and immutable, and we're going to use in a little bit more. So all right, I have a list, L equals 1, 2, 3. Put this in memory. So now, 1 in L. Is 1 in L? True. All right. Is 4 in L? False. So now we need to look at things we can do. So we can slice out an L. We can slice things out of this because same concept, indexing 0, 1, 2. So 0, 1, 2, and now lists are mutable, strings are immutable. So what in the world does this mean? So I had numbers, right? And I have L. So L index 0 is 1. But I can actually reassign this to 5. So now index 0 of L is now 5. Because I said so right here. Now, because a list is mutable, can be changed. Immutable cannot be changed. So now I look at numbers and I just say, okay, I want numbers index 0. I want to change that to 0. Well, I got to have a string. Oops. No. Okay. You cannot change a string. So we needed to talk about this very early on. Containers are, lists and dictionaries are mutable. Strings and tuples are immutable. So I wanted to make sure we cover that. Okay? Good luck on the exercises. All right, it is time to talk about a very awesome built-in function called len. And it's literally len. Let's see what it does. Well, you can look at it that way, or we can run help on len. Return the number of items in a container. So if I run len on L, I get 3. So this is a perfect way for me to know how long something is, so I can go and iterate through it and how many iterations I'm going to expect to have. So let's play around with some exercises and we'll get right back to it. Okay, we need to look at more with for loops and really start to dig into it. So for loop and the control around what the indentation does and what you need to know about it. For I in range 3. And let's get a count. Let's start here at 0. So now this is very important. So count, increment up by 1, or print and print count. So I want you to think about this. So I'm starting at 0, but what will come out each time? So I'm doing this 3 times. So is 0, 1, 2 going to come out, or is 1, 2, 3 going to come out? Whatever you can just think to yourself, and you may or may not be surprised, but 1, 2, 3 is going to come out. You might say, whoa, you're starting at 0. But my order right here is add to it, then print it out. So if I wanted 0, 1, 2, 3, 0, 1, 2, I would move count the incrementation below it, 0, 1, 2. This is the beginnings of, so now if I come outside my loop at the end after my execution, now what will happen? So I'll still get 3 printouts because I'm inside my body, but then I will get a 4th. So I'll have 0, 1, 2, 3, and then it'll end. So 0, 1, 2, 3, and that's it. So now what you're going to do in this exercise is you're going to count down and then blast off. So there we go. Good luck. All right, everybody, we need to talk about a little bit more about for loops. So one of the things that is so powerful about for loops, you could nest them, layer them, multiple for loops. Let's just look at it. All right, for range in 3, and print I, then for j, and we'll do, if I can type today, print j. So first off, you might be saying why. Well, let's just look at this. Comment that out. So to remind everybody, what this is doing right here is it's going to start at 0, correct? So 0, 1, 2. So that's 3 numbers. That's pretty self-explanatory. But now, when I do this, each time through, so it's going to do this one time through, and then this, until this is exhausted, and then come back up here. So just so we can see, because we're learning about our steps and our control of flow. So I'm going to do this little break right here so we can see this. So I'm going to rerun this. 0, then 0, 1, 2. So let's break this up so we can really see how these break out. All right, so here is our original 0, 1, 2, 0, 1, 2, then these right here. So we're going to do this full loop 3 times. First time, 0, then down to here, 0, 1, 2. So to make this clear, how about we make this 1 through 4. 1, 2, 3. Yep. Let's do this really, really well so we can see this completely and break this out. So here's our 0, 1, 2. Then we have our 1, 2, 3, 1, 2, 3, 1, 2, 3. This is the beginnings of power of a nested for loop. So in your exercise, what you're going to be doing is I'm going to give you an x value, an x variable assigned to 0, and a y variable assigned to 0. And then I want you to increment the x at one level and increment the y at another level. So when we get done, the y will be a different value than the x, because one will go through here 3 times and one will go through here 9 times. 3, 3, 3, 9. So there we go. This is the beginnings of very, very powerful, awesome things that we can do with for loops and even nested for loops. All right, good luck with the exercise. Okay, we've been talking a while and you've done quite a few exercises now. So I want to deal with this and show you this very early on in our adventure. So I just got 2 new variables over here, A and B. So there's a lot of things that sets Python apart from other languages. What I'm about to show you is one of the very cool features. Other languages, you need to have temporary variables. So if I want to swap the information associated with this variables, there is one very cool technique, and I literally just change the order and assign them. So right now, A is 1 and B is 2, right? So A, B equals B, A. Completely legal. And this is going to come up in one of our exercises and one of the very notable math sequences of Fibonacci sequences. This is a very important feature. So now I said A was 1 and B was 2. So now A is 2 and B is 1. So we will be we will be doing some very cool exercises with this, but I wanted to make sure you saw this very early on in your journey, and you've seen assignments, and you know how to do it. So this is a completely legal technique, and we will even do more with it. So there we go. See you next video. All right, so we know about true and we know about false. We know that they are the beginnings of how we begin to make decisions and make tests. Well, you also need to know that there is a numeral equivalent, and I use that term exactly for that reason. There is an equivalent to true, it's 1, and there's an equivalent to false, and it is 0. So there we go. So, and so 1 equals 0, it's false. So whenever if you've already run across and you're like, what in the world does that mean? Well, 0 is an equivalent in a Boolean test to false, and if you get a result of 1, it is the equivalent of a Boolean test of 0. So just wanted to make sure you had that. Now let's do some exercises. All right, everybody, welcome back. We need to talk about something that we visited at the end of last section, and it's what we're going to be using going forward. We need to talk about the keyword return, and we haven't talked about it in a minute, but it means create. And the reason why this is important is because the labs going forward, I want to be able to start giving more tests, and that's on the side that I control. But tests to check your work, and just going forward, we're going to be creating variables and using return. So let me just show you. So we have name, doesn't take anything in, and let's just look at this. And right now we just print Sam. So then I call name and I run it. But name, but I don't do anything with it. But now if I return, I can then do things with this. And now, okay, so see, this is where, all right, and then I run print on name, boom, because something is being created, and then we can actually assign this to a variable because something's actually being created. Print just puts it out to the screen. Nothing is actually initiated or created. It's just following the instructions. This means I have a substance. So all right, so going forward, every example that you're going to see me use is going to have return in it, and every problem, every lab you're going to do in between is going to need a return statement, because I want to be able to test it and give you as much real world experience. All right, hi everybody, welcome back. We need to talk about one more keyword that is very powerful, elif. So we know how to handle the 2 options. What happens if it's 3 or more? So let's just look at it. Metals. So all right. So in competition, first, second, third, gold, silver, bronze. We have 3 options. So if X equals first, they get gold. All right, then normally we just see this and we return silver. Okay, but we have a problem that there's another option. So this is where the elif comes in. If X equals 2, return silver, and then the else catch-all bronze. So all right, here we go. Let's put this in metal first, return gold, then silver, then 3 bronze. Now there is a problem here. So if I were to put in 5, we can deal with this later. They're all bronze. But what the real takeaway here is how to handle with more than one condition. And we're going to talk more about this in depth as we go through our journey and see how to control the order. But the general rule of thumb is if this fails, because at first glance you might go, why don't I just put a bunch of ifs? That's a very good question. But the problem is Python understands that you would just have a continual list of ifs here, and it will check all of them. But the point of this is to control the flow and your speed. So once you begin to learn to program, you want to then make your program efficient. So you want this to, once you find and stop and have the answer, you want to stop looking. That's why elif and else is correct, because it would come down here and check every single one. So there we go. Now, the exercise is going to be, just think about it. What we're going to do is we're going to do positive, negative, and you need to check for 0. So there we go. Have fun with the exercise. All right, everybody, welcome back. So let's just wrap up a last little function, and we're going to take in multiple variables, multiple arguments. So if you've not seen total, so now, all right, so what we're going to do here is we're going to use our, and then we're going to add x and y. So I'm going to return x plus y. So then total 3 and 4. Copy, paste. All right, this isn't going to be too difficult, as we can see, but your assignment when we get done talking. So this is one of the things, let's do that. This is one of the things that where Python becomes, so we've seen empty, we've seen one argument, now we have more than one here. And there's actually ways of handling that, and we'll deal with that later when we continue on in our journey. But this is the next layer in sophistication. So we take in 2 arguments, and then we do stuff with them. So, all right, now I kind of want to show you something right here. We touched on it, and we'll touch more on it. So right now I'm running this, but I haven't done anything with it because we're just returning. So now I'm going to print this out. All right, so to get this to come out and to print, we need to wrap our print function around this because we're creating something, but we haven't called it. So here we go. So 3 plus 4, 7. 2 plus 1, 3. 1 plus 9, 10. And of course, 2 plus 4. 4 plus 2 is 6. So what you're going to do in your next exercise is I want you to create a function. I'm going to have it kind of laid out. I'll lay out the top. You're going to take in, I'll leave the argument section blank. You're going to take in the length and the width, and you're going to find area. So the title of the exercise, the title of the function, the name of the function is going to be area. So you're going to take the length and the width as the argument, and then you're going to return length times width. So all right, there we go. Good luck. And then there'll be one more video after this, kind of wrapping it all up. See you then. Okay, everybody. Welcome back. Hope everybody has enjoyed this beginner section. So you are probably feeling very overwhelmed right now, and that is completely normal. That is everybody's part of everybody's journey. So what we're going to do going forward is then, now that you have a basic concept, we're going to then break it down into sections of more with strings, more with math, more with we're going to break it down into sections, more with math, more with print, more with functions, and we're just going to, so you can bounce around, and there it'll be beginner. We might go up to intermediate, but it will still stay very basic. But I've been thinking about this for a very, very long time. But we're going to then have sections, and you can bounce around inside the section. Instead of going straight to an intermediary, we might have we're going to have a problem solving section, and a lot more with strings, a lot more with floats, and a lot more with integers. And those are going to be their own sections. But I want to encourage you. I want to make sure you're reaching out to me. If you have not reached out to me yet, that's what the Discord server is there for, that I'm here to help you guys. But do not worry about going through this alone. All right, see you in the next section. Hi, everybody. Welcome back. Welcome to the list section. So, all right, everything that we've been dealing with so far, we've been learning a lot about Python, and every variable is an object. Almost everything in Python is an object. We are really going to delve into lists this week, this section. So, all right. Lists live inside square brackets, just like strings live inside quotations. Everything inside these square brackets are contents of a list. So let's just talk about what is a list. Well, it is defined as a container. Just think about a box. And the very cool thing about a Python container list is you can put an infinite number of items in this container. And what is very interesting is, just like a box, you can put, like if you get a case of shoes, you can have multiple boxes inside that. Well, one of the very cool things is that you can actually put other boxes, other lists inside that can be larger than the original. But all right, let's just show you. So I put this into memory, and so I ran type on my square brackets, and Python returned a list, that to show that I know what I'm talking about. So now this variable L1 is a list. And what is very, very cool is, just like a container where you can pick it up, move it around, take things out, look at them, put them back in, shuffle them around, reorder them, organize them, and keep doing this. Now, one of the very important features of a list is, we talked about mutable and immutable. A list is mutable. You can change it, and that is one of the very powerful things you can do with a list. So, all right, let's get at it. All right, welcome back. Let's go ahead, and we're going to have L1 equals 1, 4, 6. Then L2 equals 3, 3, Sam, and 1.2. So, all right, this is super important. Like I said before, you can place anything inside this container. So let's put these into memory. So I call L1 and I call L2. All right. So as we can see here, L1 is a list of 3 objects. Yeah, L1. Length of 3. Then L2. Also 3. Now, this is where it gets very, very cool. So L1 plus L2, I can actually concatenate, stick these together, and Python completely understands. So then when I call L1, I still have that. L2 is sitting right here, but I can literally place in anything that I would like. So I have my string, and in one I have all integers. The net L2, I have an integer, a string, and a float. This is completely legal. And then what I did here is I combined them. So I could take L3 and then have it equal to L2. So then when I call L3, boom, I have my lists of two combined lists right here. All right, so we need to look at the methods right here. Dir on list. All right. Okay, so we're going to go through all of these, and you're going to have some exercises. But these are our methods: append, clear, copy, count, extend, index, insert, pop, remove, reverse, and sort. All right, let's go ahead and get at it. All right, welcome back. So we need to look at the extend method. So let's just bring this in. So we can do this one of two ways. I can run dir on list, or I can then also run dir on a variable that is a list, and I get the same result. So now I said we were going to look at extend first. So then I can run help on list.extend. All right, extend a list by appending elements from an iterable. All right, now, so let's look at this. Now you're going to hear me talk about, you've heard me talk about return when we're creating our own function. So there are a lot of things that Python does super well. This is one of the functions, methods that, and we really need to dig into this. So a method and a function act the same. We use them basically the same with parentheses, but the way in which we invoke them, call them, is different. So it is associated with a specific variable. So I'm going to, so before what I did is when we did L3, I combined two lists. So now, the reason why I showed you that one first is now we're going to take this and do this way. So now I have L1, then I'm going to extend L1 by L2. So this is very important right here. And this is only one of the few complaints that I want to show you this first. So this is literally going to change L1. We're not creating something new, we're appending it. So we're editing it, we're updating it. So whenever you don't see return, it means it's adjusting this variable and returning none. So I'll show you what I mean by that in a second. So now I call L2, L2 is the same, but when I call L1, it is now the same as L3. So L1 has gone away. So we need to deal with that problem later. But right now, this is how a list is extended. So I want to show you this. You may think, well, why can't we take a new variable, L4, here, let's put this back into memory. So we have L1, then L2, so then I go L4, no, L3. And we have an L3. There we go. So now I want to take L4 equals L1 dot extend. Then I extend it by L2. So I want to show you this. It doesn't create anything. It returns nothing. There is no return statement here. So what we'll see more of in the documentation is when something's being created, you see return. But most of the time you see return none. So I want you to keep this in the back of your head. This is getting to next level stuff, but this is what we do to extend a list, just like this one right here. So let's go back and do L3. L1, then we're going to extend it, you can see that, by L2. All right, then L1 is now our longer list, and we just did that twice. Okay, there we go. All right, good luck with the exercise. Welcome back, everybody. All right, now we need to look at our next method, is append. So we saw a little bit of wordage on that. So let's look at help dot list dot append. So all right, I need to show you, see here we have no return, so this is going to be appending, and I want you to look right here, end. So just like extend, it put it at the end of the list. So we take, and don't ever try to remember all of these. This is already built in for you. This is what the help function is. Try to understand what they do. Don't remember, and then you don't even have to remember all of them. That's what this is for. The most important thing about learning anything is understand how they work, not what are the tools that you have. You don't even have to remember all the tools in the toolbox. You just remember what to do with them and how you use them. Python will give you the list of everything. So all right, we're looking at append. So help.list.append. All right, append object to the end of the list. So all right, I have L1 here, and then I'm going to append it with, let's say, a string that is a 5. So now when I call L1, it placed a 5, a string of the number 5 at the end. Then L2 dot append. So here's my dot notation, and then I've already got a string in there. Now I want to show you this. Oops, didn't mean to do that one. So now this is what's very cool, and this is what I alluded to earlier. So now I have L2, a list that has how many in it? I don't need that. I don't want to have to count it. I have a tool that is going to do this for me. It has four items in it. Oh yeah, okay. So I put a string, I put a list inside a list. Oh, that's kind of cool. So now I want to show you the difference between extend and append. This is vital. So now if I go L2 dot append, then I pass in L1. This is not going to be the same functionality that list or extend did. And the reason why I show you this example is so you're not so shocked when I show you this one. So we passed in a list, so it didn't get added onto, it jumped inside the bracket as. So now when I hit enter here and I call L2 now, so now I have 1, 2, 3, 4, 5. So when I run L2 on this, I get 5 objects. So this is not an extension added to the end of it and lengthening it. it goes inside just like this. So when we use append, it gets placed inside the whole thing as an element into an index. And that's another very important feature. All right, good luck with the exercise. All right, welcome back. So I alluded a little bit here, and now we need to look at list index. So wait a minute, we know that term. So okay, help dot list dot index. Okay, index return. Aha, here we go. Return first index of value. So this is our first experience of something is being created. So whenever you see there is an absence of return, it means it is changing something, not creating something new. So now we need to look at this for a second. So we have L1, right, and L2. So same rules apply for lists that apply for strings. So we can slice, we can index. So this is where this comes. So L1, index of 0, L1, index of 0 is this item right here. 1. Index 0, 1, 2, 3. Just like our string indexing and slicing. So then if I go L2, then I go 2, and I close this out, I get 0, 1, 2. And then I can slice it as well. And so 0, 1, 2, 3, 4. So we go to 4. So it's going to have 2 and 3. 2 and 3. Same rules apply as slicing. So all right, so now let's dig into what in the world this does. So now I'm going to do index the value. So this is our first experience of looking for something, search. So I'm going to look at, I want to find 1. So I type in 1. I want to check and see, and let's look at this. So return first index of value. That is a way to say the first place in which it occurs. So if I put a second one, I need to start not at 0. And this right here, this is another first for us. This plus, or excuse me, this equal sign, this is not this isn't assigning of a value, but for us, this is a default. Where does start start? Where does it start looking? It starts looking at index 0. All right. So if I type in 1, I get index 0. Then if I look for 6, I get index 2. Let's bring L1 back down here. All right. So now this is important. All right. If it is not present, I get an error. So you're going to see your first experience if you fix the syntax. Python tells you whenever you make an error. So all right, we're checking inside. Let's do 9. Bam. 9 is not in the list. Python goes, it's not there. So all right, there we go. Let's go ahead and get after the exercises. Okay, welcome back. So now we're going to look at the pop method. One of the coolest ones that I think is out there for lists. So let's run help. I can type list.pop. So it literally does 2 things. So not only, first of all, does it remove the default, the last item, just like our indexing, negative indexing works. So it's going to kick out the last item, but then it also creates it. So, all right, let's see where we are. L2. So we have our len L2. Have 5 items. 1, 2, 3, 4, 5. So when I do this right here, L2.pop, so I don't need to pass in anything because it automatically goes to -1. the last item, this. So it returns, it creates this item. So with me doing this right here, I get a return, but I didn't assign it. I didn't store this to anything. So now let's look at L2. Okay, so now L2 is a list of 4 items, and the last one is an empty list. All right, so now watch this. So it removes and creates. So now, like I said, it returns, but we didn't assign that to anything. So I lost the opportunity to grab it. So if you want to move items, this is a perfect, if you want to pop it out of one and pop it over into another one, this is the coolest stuff. So now, if I can again type, boom. So now I have in one fell swoop, not only did I kick a item out of my list, but I then created a new variable of that item. All right, good luck with the exercise. Okay, welcome back. So now we need to look at the insert method for lists. And let's just read about it. So list.insert, we're going to see some things that we understand, but the functionality is going to be a little odd. So insert object, so we're going to have to pass it 2 arguments. Where we want it to go, well, kind of, and then what are we passing it? So all right, we have L2 right now. So now I want to insert into L2 fish. And I'm already forgetting. So I need to pass it index where I want it to go, but it's going to go before. So I want it to go before index 0. Okay. All right. So then I'm going to pass it fish. So then I call L2 and I get, well, you go, okay, but it just went at 0 where you set it. No. This was 0 and I want it to go before it. So now the reason why I'm saying this is if we recall that we can do lists also work for negative indexing. So if I slice this or index this and I get -1, I get 1.2. So now this also works. If I come here and I go -1 and let's just pass it an empty list. So now let's revisit what this does. This is my object and I want it to be inserted before -1. Here's -1. So at first thought you might go, oh, it'll just go at the -1 spot. It'll come this way. Well, let's call L2. It goes before because we don't want to have 2 functions doing the exact same thing. If I wanted to just put this at the end of the list, I would use append. But this goes right before the index. So don't think about that it's taking the spot and moving forward. It's being inserted before that index. All right, let's get after the exercises. Okay, everybody, now let's go ahead and get after this sort method. And we're just going to do what we do, and we go list dot sort. What in the whoa? Okay, now we're getting serious. All right, the sort method, sort the list in ascending order and return none. Haha. So now we're used to this. We know now we're actually seeing it. So it is going to be changing our list. So if we want to have an unchanged list, we're going to have to do something about that very soon. And guess what? We'll do that soon. A couple methods from now. So it returns none. And then here, this one is redundant, and I love it. Sort is in place. List itself is modified. stable and two equal elements is maintained. So what this is saying is that it's changing your object. So if you need to keep that list and you need a new list, we need to have a new technique, and we'll solve that real soon. So okay, so now we have L1 over here, but it's not sorted. It's all out of shape, right? So now, oh, that's too much. Let's do that. So now this is how we do it. We just go L1 dot sort, and what does it say? List sorts in ascending order. So low to high. And it does it in place, so it changes the list. So now, oops. I thought this was out of order. All right, so now we need to make a new one. Let's extend this. For some reason, that's the thing about dyslexia. It plays some pretty good tricks on you. I would have bet you anything that list said 1, 6, 4. So we got 3, 7, and then let's throw in a 2. All right, let's put this back into memory. All right, then we run L1 sort, and then I call L1 1, 2, 3, 4, 5, 6, 7. Now that was completely unintentional. I did not mean to have all of the numbers there. Maybe that redoes my issue. Okay, so good luck with the exercises. Welcome back, everybody. So, all right, list count method. Let's do our thing. List.count. Okay, count value. Okay, method. Return the number. Okay, here we go. So I'm returning, so I'm creating something. Very important. Number of occurrences of value. Okay, so so we've seen a couple different terms. So this is what we're looking for. And it's going to create and return a number, the count, the number of occurrences of this value. So let's just 4, 3, 1, 4, 4, 4. Okay, memory. All right, so len.1.count, count, then 1, 2 times, 3s, 2 times, 4, 5 times. So this is a very handy tool. So you don't have to come through and sort and then go, okay, how many do I have? I can literally just say, all right, how many times do I have? And I want to remind you, here we go. So it creates so when I call 5, because I'm creating something, I'm returning. So this is how we're going to do the exercises. So I want to know how many occurrences does something have. So there we go. All right, good luck with the exercises. Okay, welcome back. So now we need to look at the remove method. Help.list.remove. Okay. Aha. Value remove first occurrence. So what don't we see right now? I do not see a return. So if I'm removing something, return first occurrence of value. So I'm going to pass in whatever I'm looking for, then I'm going to get an error if it's not present. So let's do that first. L1 remove, and let's look at 7. I get an error because 7 is not on our list. So now I want to show you this right here. Let's call L1 again so we can look it over here. All right, so I'm going to pass it 1. So which one is it going to be removed? Well, it's going to remove the first occurrence. So my list is going to get smaller by this 1 right here. So L1 dot remove 1. Then L1. Okay, so now if I pass it 1 again, my list is going to get shorter here. Let's bring this up. So now if I do 2, so here, so I'm going to go, the next one I'm going to remove is a 3. So I'm going to go 4, 4, 3, 2. 4, 4, 3, 2. So this is how this works, and we cannot control where we remove from. It's just going to remove the first occurrence. All right, good luck with the exercise. Welcome back, everybody. So now it's time to look at, you would think as many times if I've typed help, I would not need all this help. So now I want you to look at this. This one's a little odd, but when you think about it, you'll get it. So, okay, reverse, in place. So reverse method built-in list. So it's just literally going to take this and flip it around. It's not sorting it. It does not say sort, does not mean anything. Like I said, we do not have redundant methods. So we're going to take our L1. We got 1, 4, 4. On the other end, 4, 4, 4, 2. So L1 dot reverse, and it's going to do it in place. It created nothing. It returned nothing. I did not create anything. I changed it in place. So what did I say? I said 4, 4, 4, 2. 4, 4, 4, 2. It literally just took it, flipped it over, did a mirror image. All right, there we go. Good luck with the exercise. Welcome back, everybody. So now we need to look at clear, and it's pretty self-explanatory, and I'll show you another way to do it, but it's just so we can have them, know them, and understand them. Clear. What does list clear do? Remove all item from list. So we have our L2, so we have our L1, and then we can do this. Dot clear. It's going to remove all items. Now, we can also reassign it. So we have L1, and if we are doing a loop and at some point we need it to start back over, we can also just reassign. Just like that. So I wanted you to see it right there. Wanted to show you always. All right, good luck with the exercise. Welcome back, everybody. So now we need to look at the problems that we've had and how to handle when we're changing a list in place. All right, so we have had a variety of methods here that go in place, that change the list. But what happens if I need the original? Well, guess what? There is a method for that. L3 equals 1.copy. So now L3 is a copy of L1. Return, and what do we know about that? And we'll delve into this later, but just remember, returns a copy of the list. So there we go. All right. Good luck with the exercise. Okay, welcome back, everybody. So now we need to look at and delve into more we can do with indexing and items with the list. So we can literally, so lists are mutable. So I talked about mutable and immutable earlier, way earlier on in the course. So here's one of the powerful things about a list. You can change it. So like I said, it's a container. You can look inside of it. You can pose questions to it. You can take things out, look at them, put them someplace else, or put them back. And the very cool thing is you can put things that are larger than the box, than the container, inside that container. So now let's look at L2 here. All right. So then if I want to do L2 and index 0, I get 3. But now let's look at something weird here. So this is completely legal. So right now, L2 is integer 3, string Sam, float 1.2. So now when I called this index, it spit out 3. So now, what do we think this will do? Tom. So now I literally reassigned index 0 to Tom. So let that sink in for a second. So what I did is this is mutable. This is changeable. We cannot do this with strings. Strings are immutable, unchangeable. I took out from index 0, took it out, and I reassigned, and I put something else right back in its location, and I reassigned it. So there we go. Good luck with the exercises. Hey everybody, one last lesson for this section. So all right now I have string S, string T, or a string assigned to S and a string assigned to T. So now let's look at this feature right here. This is a little interesting. So I can actually take that string, wrap it with list, and I actually then new dot S. I actually then turn that string into a list of each individual index. So this is a very handy tool right here. And also, when we were making a new list, so I showed you how to then, we could use clear and we could use brackets. Then also L5, I can literally just go list. So now L5 is an empty list. So this is a very powerful LT equals list dot T. Same thing, new T. It will chop up that string and turn it into list with each individual item. So there we go. We'll give you one exercise, then we'll wrap this up. Okay, everybody, that concludes our third section, our list section. Do not be concerned if this is a lot or overwhelming. This course is being laid out to ensure that you understand, comprehend, will review, and also be able to replicate these items. So as you can see, we're going to move back and forth. We're going to move forward, then we're going to come back, and we're going to revisit all of these things. Like, that's why I wanted to just have an entire section about lists. So I do not want you, just because if you think that you cannot get this or you don't get this right now, guess what? The next section is going to be a standalone section about an object. So we are going to do that. We're going to do it together, and that's what the Discord server is there for you to reach out and ask questions so you're not alone. So there we go. You are going to do fine. See you next section.